This is a video for day 7, actually, of orders of operations. This is the vocabulary we're learning for today. Simplify means replacing an expression to its simplest form. We get expressions in many different forms, but for example, an expression like 2 plus 3, well, 2 plus 3 we could write more simply in a new line just saying that it's 5. It's an equivalent expression. So simplifying making it the simplest form of an expression. An exponent tells how many times the base is multiplied by itself. So you could have a base of 3 and an exponent of 3, and we're saying that 3 times 3 times 3 is what 3 to the third really equals to, which is equal to 27. Evaluate. Evaluate means to solve or find the answer. So whenever you see those in the test, it just means find the answer. The orders of operations. For the most part, people know them as PEMDAS. I use them as GEMDAS. That's a grouping symbol, but P stands for parentheses. E stands for exponents. M stands for multiply. D stands for divide. A stands for add. And S stands for subtract. These are the different orders of operations. A good way to remember them, that's a classic way, is please excuse my dear Aunt Sally. So we use orders of operations when solving expressions that have multiple operations. A good way to start is to take the example and put PEMDAS next to it. That way we know what order to go in our orders of operations. So, for example, we ask ourselves, are there any parentheses to use yet? Or to simplify, no, there are not. There are exponents now. So we have 3 squared. This becomes 9 plus 8. Bring the rest of the problem down. And we're done with exponents. Next we ask ourselves, are there any multiplication symbols here? There are not any multiplication symbols. Are there any division symbols? No. Next, we want to ask ourselves, are there any addition and subtraction signs? We work from left to right, so there is a subtraction sign here before the addition sign. So we do that first. 25 minus 8 is 17, and we bring down the plus 9, and 17 plus 9 is 26. For example number 2, again, it's the same concept. Put PEMDAS on the side. And we work it out. Are there any parentheses? No. Are there any exponents? Yes, we have this 4 squared here, which becomes 16. There's a subtraction, divide by 2. And there's a 6 times 3. Okay, continuing, now we ask ourselves, are there any multiplication signs? Yes, there's a multiplication sign, and it is before the division sign. Like adding and subtracting, you work from left to right. So 3 times 6 is 18. And then we have negative 16 divided by 2 is negative 8. 18 minus 8 is 10. Is your final answer. Continuing on, example 2. Evaluating an algebraic expression. This is when we substitute a value for a letter. So we substitute a value of 7 for A. Substitute a value for A, which is going to be 7, it says here, and for B it's going to be 4. So for example, we have an expression here. It says 3a squared minus 2 to the third power, all divided by b. When we look at the problem, we want to rewrite it first so we have some room to work with. Whenever we have a variable, we want to replace the variable with the number it's supposed to be substituted with and parentheses. So it's going to be 3, open parentheses. A is equal to 7, so put 7 inside parentheses, and we square it. Subtract 2 to the third power, divide that by b. b is 4, so we put 4 into parentheses. Then we work it out with our orders of operations. It's nice to write down PEMDAS on the side so you get used to knowing what order they're in. Are there any parentheses? Well, there's the 7 and the 4, so we asked, is there anything inside the 7 and the 4 that we can simplify? And there really is not. So parentheses are automatically done. Exponents. There's 7 squared here, so 7 squared becomes 49. Put that into its own parentheses. So it's 3 times 49 minus 2 cubed. 2 cubed is going to be 2 times 2, which is 4, times 2 again is 8. All that divided by 4. Continuing on, 3 times 49 is next, which is going to be 147. Negative 8 divided by 4 is negative 2. So the answer is equal to 145. Continuing on here. Example 2. Example 2, same example. We start off, rewrite the expression d plus 6c divided by 4. Substitute. For c we're going to put d, and for c we're going to put 2, and for d we're going to put 5. So d will be 5, so d becomes 5. Close parentheses, plus 6 times c, c is 2, divided by 4. Then we work on our orders of operations, PEMDAS. Ask ourselves, are there any parentheses to work with right now? No, there are not. Exponents. There are no exponents here. Multiplication and division. We have 6 times 2, which is 12, divided by 4. Bring down the 5. 12 divided by 4 now is going to be 3. So we have 5 plus 3, which is going to be 8. We're all done with the orders of operations. Orders of operations are pretty simple and straightforward. You can use them for simplifying a variety of expressions. This will conclude our lesson for orders of operations.